Welcome again to the Southwest Climate Podcast. Mike Crimmins, good to see you.
Zack, good to see you. Did you recover from Thanksgiving?
I did. I
Yeah,
did. Yeah, it
good.
was it was a whirlwind tour. I
Oh,
flew back.
did you go back east?
No, I went. I have a project in Kenya, so I flew to northern Kenya, spent a week there. Was totally off kilter because of the jet lag. Flew back late Saturday night, early Sunday morning, jumped into a car and drove up to Colorado, where my part of my family is.
Holy moly.
It was
That's the
fun.
planes, trains, and automobile kind of Thanksgiving right there.
It was, but we got some snow and we were in the La Salle Mountains close to Moab. And I don't know, man. There's just something about waking up to, the sort of quiet feeling of snow falling, 6 inches of snow. It was fantastic.
I miss the idea of that. I'm not sure I miss it actually. I miss the idea of it.
We also forgot like all of our snow gear. And so, which is a really bummer with the 5-year-old because all he wants to do
Yeah.
is play with his trucks out there. So I had to like cut garbage bags and make like snow pants for him.
That's actually a better way to, you shouldn't buy snow pants for kids because they grow out of them every like 3 days. So garbage bags are a much better idea.
It worked. It totally worked.
Gosh, I wish I would have done that. That makes a lot of sense.
Yeah.
Uh,
So I've recovered. I'm feeling good. How you feeling?
I'm good. I'm ready. I'm like Christmas started like 3 months ago, so like let's do this.
All right, so the big question for you that I just want to start this off with, because this is the December edition,
Yeah, yeah.
and 2024 is for us in the books after this episode. So what do you think 2024 will be known for in terms of the Southwest climate? Like, what will the Southwest climate be known for in 2024?
I think it's gonna be I think it's gonna be the fall heat wave because of recency bias, right?
Yep.
But the interesting thing is that this year was so nuts that we forget how cool and wet it was last like January, February, and into March, and actually how like pleasant it was last spring. And then we got clobbered by the summertime, and then the monsoon retreated, and then we got clubbed over the head by the September, October heat wave.
Had the So I had the same one. Actually, you said the two that I was going to bring up, which is I think it's going to be known for that heat wave. October, like the first half of October was miserable. That's what I that'll stick with me for a long time. And then also the really wet early, quote unquote monsoon, which we debated about ad nauseum whether or not it was
Yeah, yeah,
monsoon, but like, the Alberto fueled, basically that was the heart of the monsoon and it happened in June. So I think those are the two things that stand out.
yeah. It's wild. I was looking at some data and some plots, kind of prepping here, and j just pulling up the Tucson one for the calendar year. Tucson's going to end up, even if it doesn't rain again this month, it's going to end up above average, and that's
That's
based,
so.
yeah, that's based on we finished by April 1st, Tucson was twice its average cumulative precip it would have had from January 1st to April 1st. So it was already way ahead. And then the airport did okay during the monsoon, even though a lot of the rest of the region didn't. So like those two together, you can't find that same pattern if you poke at all the other stations around the state. Flagstaff looks kind of that way, but Phoenix didn't get as much winter, didn't get as much summer, and then they got the heat on top of it. Albuquerque's kind of the same thing. Not as much. They didn't do as well last winter, and then certainly didn't do as well this last summer as well. So, it's like in my backyard, it's kind of weird. Feels so, it's been so warm and so dry for so long now. I forgot how pleasant it was just 300 days ago.
I have a really hard time remembering winters. Like I
Yeah,
I can remember the summer more than I don't, it's not clear to me what the heck happened just like, 12 months ago, 9 months ago.
I literally cannot. I can't remember it raining as much as it did. I have no recollection of it at all. Could be my age, but could be something else too, I
I
guess.
think it has to do like the winter is a slow roll, right?
Yeah,
Like
yeah,
it's sort of the accumulation of things. It's sort of like the NBA basketball season where like you don't necessarily remember any one games because they're not as consequential because the season is long. Whereas like the monsoon, maybe it's more like the NFL season, right? Like where every game,
yeah,
the college football season, where every game kind of like has a sort of heightened importance, like every week or every event sort of sticks out. And they're more extreme. Well,
yeah.
football's more violent for one. So
Yeah.
I'm just like, it's hard to remember. Yeah, it's hard to remember the winners for me. Okay, so here's the outline. Tell me what you think. Let's do a little bit of a focus on what happened and why in November, and then maybe a dive into the intensification of the Southwest winter season. That's kind of a question. Like, has it intensified? There's a new paper that we could talk about that sort of attacks this question that I think it has some interesting things in it.
Should I have read it?
you you were you were supposed to read
Oh,
it.
that's right. I'm gonna just be honest that I didn't read it.
You don't need to have read it. I'll go over it, and I think there's ideas in there that we've thought about that we had to have thought about for in a lot of different ways. So
Yeah.
it's
I mean, I printed it out. I have it in my hand. I didn't quite get to it by the time of podcast
well,
reporting.
all you have to do now is print out these papers, feed it into like an AI generated podcast machine, and it'll make a podcast for you, right?
Well,
So
what
then
are we doing here? What are
that's the next step.
I know. You know what?
I mean, that's literally a tool, though. I'm not. So you showed me, no, or Ben showed it to us.
No, I did it. I actually did. I fed one of my papers into it, and it was way more interesting than what I wrote. So that was kind of it. I thought that was kind of fascinating.
Yeah, it actually came up with like really colorful metaphors.
Yes, yeah. Yeah, that I one of this paper I'm working on, I had it generate a podcast. And I was like, gosh, this is really interesting. And I went back to the paper and I'm like, this paper sucks.
Do you remember that tool? Just so we can.
It's Gemini. Yeah, it's one of the Gemini, it's Google Gemini and it's the notebook tool, I think.
People can find it.
Yeah.
Podcast
It's worth
AI.
playing with. Don't tell your kids in school about it though.
Yeah, yeah. Okay. And then let's turn to ENSO and what that means for the Southwest. And a little teaser here is that the La Nina outlook and the precipitation forecast are kind of at odds, or maybe not at odds, but they're different than you would otherwise expect.
Yeah. Yeah, they're not scaling together. That's right.
Yeah,
Yep.
we'll talk a little bit about that.
Yeah.
All right, so focus on this month and this season. So maybe just to start this off, Mike, what is your general interest level in the fall season here? In this,
It's a good question. You know, we had some banter on Slack, and I just for fun pulled up the number of days with precip in November, and just this was just for Tucson, right? And for some reason, I've lived here for a long time, but I always thought it was wetter than it really was, and that every year was just like, oh, it's just another dry November, and it's just November is kind of like a wash for me. Like I could probably, I mean, I like it because it's finally sun angles low.
it's
I like
pleasant.
I like it. Yeah, the day lengths are pleasant. Temps are usually pretty good, but I don't have a lot of recollections of it of wet days.
Yeah.
And the data show that for Tucson in anyways is like, you know, at most like 6 days with rain above 100th of an inch in the last like 50 years. It's kind of interesting.
Wait, let me see if I understand that correctly. So there's just been 6 days in the last 50 years, did you say, with rain and no, not you, I must have misunderstood you.
If you look at the like variability from year to year, and this is
There's on average 6 days of rain in the month of November.
no, like at most, like on
Oh, at
average,
most.
yeah, on average, it's like 2.
Yeah. Okay. I got
Yeah.
you. Yeah, at
Yeah.
most 6. So, I also like sort of digged into this a little bit and was just looking at like averages across climate divisions. So the big climate division that Tucson is in, it's called the Southeast Climate Division, basically goes from sort of Lukeville to the west all the way to the New Mexico border, and maybe the northern extension of it is Tucson. Actually goes a little bit
Yeah.
further.
Graham and Greenlee counties are in there as well. Goes a little bit
Yeah.
further north.
Yeah, but it's a big. Anyway, that's the sort of area that I'm looking at here. So the average or the median is a little bit above a half an inch for November. And that is the Southeast Climate Division. And then when you look at, let's do the South Central, which is the greater, let's say the greater Phoenix area. It's a little bit less, but still in that neighborhood. Interestingly, though, the variability is quite high.
Yeah.
I mean, they're low values, but you can get. So this is strange. Oh no, sorry, I missed a decimal point. I'm looking at the values being 25 and it's 2.5 inches. So I'm right. I'm looking at the right thing. So the variability can be anywhere from 0 or has been anywhere from 0 to 2.5 inches in that averaged over that central climate division, South Central Climate Division. And it's similar for Tucson. So that's quite a big range. It's I guess I would say like outside of the May and June, April, May, June areas, it's similar to the variability in the months outside of the April, May, June months. So I
Yeah.
mean, you can experience some years, yeah, with 6 but more with 2, 1, 0.
Yeah. Do,
0 this year for
do you
Tucson.
remember can you remember? I mean, this is kind of a goofy question because we just talked about how we can't remember anything. But do you have a recollection of the wettest November in recent memory?
Yeah, that's a good one.
There's always the L
I
tour.
do. Okay, wait. So was that the year that there was like weird monsoonal, like it felt like the monsoon in early November? Do you remember that year? It was like 3 years ago.
Yeah, I do.
That November?
It was October,
Yeah.
but it might have. I don't know how long it lingered, but I do remember that it was like that was actually more recent than the one I was thinking about. But that was in the last couple of years where we ended up. It was one of the post really wet summers of like 21 or 22 that it just kind of never ended sort of thing. It was really weird.
All right, what about the year? And it was before I got here. Maybe it was like 2004, 2005, where a lot of landslides happen on Lemon. Was that November?
The landslides on Lemon, I think, were from the monsoon, and that was in 2006. I
Yeah.
think that was the heavy monsoon.
I thought that was the fall.
Yeah, I don't know. I can't remember that. I cue in on so in Sonoran Desert, the fall precip, and it really is kind of November, cues up the wildflower season in the spring. And and again, I didn't remember this until I like looked at the data we were just talking about. But 2019 was really wet in November and led to a super bloom in spring of 2020, just as everything was closing down and going nuts and that kind of stuff. And it
Poppy Apocalypse?
the
The
apoc that that
apocalypse?
apocalypse, right? That one. And but it created all of this fine fuel for the Bighorn fire and the crap monsoon of 2020.
Huh.
So it's kind of interesting is like the fall season it's kind of I don't know, it fades to the background a lot of times unless it's wet. And then it usually does produce at least in the Sonoran Desert, a big flush of spring wildflowers that then turns into stuff to burn later on.
Yeah. So do you remember, was that like a sort of an atmospheric river induced? You don't remember? Yeah.
I don't remember. I think it was just, it was kind of mid-latitude storms rolling through. I mean, it was several of them in that particular season, and it kind of stood out because it wasn't, it's hard to remember that. It's always when if it ever rains on El Tour, it usually, which is the big
Oh,
bike race
yeah.
and I think it may have done that year, just because it creates all sorts of havoc here in Tucson when it does.
Yep. I remember that. Like 6,000 people sign up for that event, and I think ended up like 2,000 people finished.
Yeah, exactly. Like maybe not today. Yeah.
Yeah. Um, what about December though?
Like
Is
what do
that
I think about?
does that drive more interest for you? Because
You
I'm
know,
with you. I'm with you. Like November is sort of blah to me. It's
yeah,
pleasant. Like it's
yeah, it's a weird transition month, especially for here in Arizona. If you go well further north, right, you're usually starting to get clipped by the mid-latitude storms. And I think northern Arizona has actually done quite well in a couple of events in November. Further south here, we have to wait. It's both in Arizona and New Mexico. By December, we should be starting to that storm track should start to settle a little bit further south. So we have a little bit better opportunity for storms. And it's usually like holiday break towards the end of the month. You will start to see those climatological precip chances go up for the southern half of the Southwest. And so I'm kind of I'm holding out now because it's been pretty sparse here in southern Arizona as far as precip events.
so just in terms of the climatology of the winter, and I'm gonna eyeball these numbers because I'm looking at a graph. And again, this is a Southeast Climate Division, so it would encapsulate Tucson. October would be probably zero point 0.6 inches of rain. November is slightly more, let's call it zero point 0.6. December is 1 inch. January is an inch. February is probably zero point 0.8. And March is probably zero point 0.6 again.
Yeah,
So,
yeah,
it's fairly like in low values, but fairly consistent, I guess, with
yeah,
December and January and February being sort of the more of the heart of the of the cool season, as we call it.
right, right.
Can't call it the wet season because that would be a misnomer.
I
So,
know, yeah, it doesn't work. Doesn't work.
all right. So what happened? What happened in November, Mike? It's been a little bit of a mixed bag, right? Like you look at the rainfall at the Tucson airport, the Phoenix airport, nothing. In fact, actually, it's been fairly dry outside of southeast New Mexico for November. A little bit north of Arizona, New Mexico. However, there's been more precip there. And in terms of temperature, it's been cooler than average. I think Phoenix and Tucson airports were a little bit over an inch cooler than average for November.
Did you say
So
did you say an inch cooler?
I did. I said an inch cooler.
That's I
That's where I
love
am.
that. I love that. I love the idea of like a wall thermometer.
Yeah,
And then
it's
yeah,
a measurement of the geopotential height.
I think that's I think it's actually, you know what? You saved yourself. That actually works.
A degree Fahrenheit cooler.
It's good. No, I love it. I love
Thank
it. That's fantastic. Yeah,
Which
dude, there's
I
not
wish
much
I
to
could blame this on jet lag.
I you're getting older, man. I see the gray hairs coming in. You're catching up on me here.
So
Yeah, it's
what's happened?
not much. It's like
It's
really
been cooler
benign.
though, so it's not like it's been a in it's not like we haven't had systems run through the region.
No, it's been quite active across the Pacific, and the West Coast has actually gotten hammered. So if you're in the Pacific Northwest, you've actually had quite an epic November. And so there's been these wave trains moving across the West. We've just been too far south to really get much activity from them. So if you remember, hate to bring it up again, but the heat of late September and October, Broad Ridge just wouldn't let go and settled right overhead. And we just baked and had a run of record high temperatures across Southwest that just wouldn't end. But it actually broke mid-month, and we started to then see these troughs of low pressure make it as far south as the Southwest. So we would get this roller coaster of it'd warm up a couple days to average, maybe a little bit above average, and then we'd have a windy system come through that was dry and drop the temperatures down. And that happened quite a bit. We had one event that was right at the beginning of the month that was a very heavy rain event for the Pacific Northwest, Northern California. That was a slow trough that actually became positively tilted. So it was like tilted towards the east, and a low pressure system basically formed overhead and was able to pick up a little bit of subtropical moisture. And it was moving quick enough where most of that moisture fell across southeast Arizona, a little bit up into northeast Arizona. It really left much of the western part of the state dry, and then moved into New Mexico and was a decent event. It was actually really one of the only events for Arizona.
Wait, so
Um,
what dates are we talking about?
this would have been the second and third.
Okay, so early November.
It was early November. Yeah, and kind of prior to that, New Mexico has had a very interesting fall. Eastern New Mexico has had some heavy rain events kind of repeatedly, and they even had a decent one right at the beginning of the month. This event came through and brought them some good precipitation, like as you mentioned, to southeast New Mexico. And this event moved out of Arizona pretty quickly, lingered as a trough across the Southwest for a couple of days and brought more precipitation to New Mexico, and actually developed into another low right around the 7th that wound up pulling more moisture from the east into New Mexico. And
Mm.
that actually took several days to actually get out of the region and brought more heavy rain to eastern New Mexico, and then finally got picked up and moved out by the 9th or the 10th. So Arizona didn't see anything really of consequence during that event that lasted for almost a week for eastern New Mexico. After that, the we were kind of in that roller coaster of ridge trough. So we had warm ups, cool downs through like the middle of the month, and then by the time we got to just before Thanksgiving, the ridge built back across the west. We warmed up, dried out, temperatures went above average. I think there was even one record high. Phoenix set a record high for the day, I think the third week of the month, and Tucson came close. So it was like it started. It was the weird thing too. When you get the heat waves across the Southwest, when the sun is so low, it feels like if you're in the sun, it feels hot, but if you go behind a tree, it's like it's cold. So they're really strange feeling events, but they were above average. And we just kind of ran out the month with again, California and the Pacific Northwest, we're seeing all sorts of atmospheric rivers, and we were just out of reach of us, and kind of leads us to today. So the southern part of the Southwest really kind of missed out on a lot of this, except for that one event we had earlier in the month.
Yeah, and I'm looking at Albuquerque, and in November, they basically got probably an inch and a quarter total, but six to seven of wait, one, two, three, four, five, six events in Albuquerque. Again, Tucson had nothing at the airport.
Yeah, yep,
And then Las Cruces area similarly, and it had close to an inch and a quarter. So above average there for both of them.
right.
Flagstaff had just a wee bit in November. Again, October was a different story. So there was a little bit of precip in late October, but forget about that in Flagstaff. So in November for Flagstaff, just actually a day with a little bit of snow and a day with a little bit of rain. Phoenix hasn't had rain. This plot only goes back to October. So in both October and November has not had any rain. And Tucson just had that one event that you talked about in early November. So I made a mistake. Let me correct that. So Tucson actually has experienced some rain in November. It was the one event that you were talking about in like around November 3rd. And it wasn't actually insignificant. It dropped like 0.43 inches at the airport. I don't think I was around then. That's my excuse.
It seems reasonable.
Yeah. You also mentioned you also mentioned the West Coast has been fairly active, basically from northern central California up through Oregon for the most part, and
Yeah.
sort of punctuated by, and I was gone for this, but I was paying attention, but punctuated by a pretty strong atmospheric river in like around the 23rd, if I remember correctly, of November, kind of doused, California, San Francisco area, Northern California, Southern Oregon, pretty significantly. And I think actually this is the event that as it waned, some of the moisture actually wafted into where I was for Thanksgiving around the 27th and led to snow and rain in the deserts of Utah.
Yeah, I think it was around mid-month too. Do you remember reading about the bomb cyclone that was in the Pacific?
Yep.
Right? I mean, you can, and that was one of the feeders for some of the atmospheric rivers that hit a little bit further north. And I remember watching that on the weather maps, but the central low pressure was hurricane low with that event. It was really strange too, because it formed and then it retrograded back to the north west. So you could see it on the weather maps, but it didn't crash on land like that level, but was enough to have that pressure gradient just feed the filaments of the atmospheric rivers up into the Pacific Northwest.
Yeah, so I'm looking at a some data that looks at the last month from November 5th through December 5th and ranks the amount of rainfall that fell in that month period of the last month historically. So ranks them. Ray is that Santa Rosa. So a lot of places north of San Francisco actually experience like top five
Yeah,
rainfall. Santa Rosa, the little bit north of San Francisco, it's wettest on record, 15 inches. So
bonkers.
yeah,
Wow.
so and you go a little bit further north. What's this? Um, Even all the way up to the border, Crescent City, seventh wettest on record there for the last month. So that, I mean, these are events, Mike, these atmospheric river of events. I mean, they're juicy. They're always juicy, right? And this one was
Yeah.
a pretty significant one. And they're normally going to lead to sort of record setting somewhere. It seems,
Yeah. Yeah.
and yeah. Anyway, anything else to say about that event?
No, no, I mean it's if you think of right the climatology of the whole Western US, it's interesting that I remember reading about this in the Pacific Northwest that they have a double maximum as the mid-latitude storm track comes into the Pacific Northwest in the fall, kind of falls, it goes south, so it quiets down a little bit and then retreats back north through the spring. So, we're kind of right on track for the climatological progression of the storm track southward, but it's been pretty impressive of the strength of those storms that have been crashing on the West Coast over the last month or so.
So did that event like remind you of anything? Because it caused me to think about 2022, 2023.
Mm.
You remember that?
You're talking like more in the December, January
Well,
timeframe?
specifically the December
Yeah,
2022, where
yeah,
um, there was a large, if there might have been a couple actual atmospheric
yeah,
rivers, right?
yeah,
And that was the summer, not the summer. There I go again. That was the winter, I think, that set records in a lot of different places for rainfall for the entire season. It was sort of an event that stood out and contributed. I mean, the rest of the year, the rest of that winter was rainy. Wasn't like
mhm,
it was the only rainfall event of that winter, but but it propped the statistics. So that area, California, actually even into Nevada, like you could see the expression of the atmospheric rivers on a map of the season, had exceptionally large values. And I don't know,
Yeah.
that was
Yeah.
I don't remember an atmospheric river capturing my imagination last year as much as the 2022 event did.
No, I agree. They were pretty showy, and I mean, I think they reached down here as well. So that they catch my attention when they bring rain to the Southwest.
Yeah, so I bring that up because I was sort of interested in that 2022-2023 event. There was let me say it this way. There was a paper that was passed to me that basically asked the question, focusing on the 2022-2023 season, and was like, there is an expectation in a warming world that cool season being what the November through March period. There's an expectation that cool season rainfall will intensify, and that's basically what this paper sort of interrogated. So I thought it might be worth just talking about it a little bit. And it's done by our own Kevin Anchikaitis. He's a co-author on it. It's led by Park Williams. For those interested, we'll paste it in the show notes, but it's got the title "Anthropogenic Intensification of Cool Season Precipitation is Not Yet Detectable Across the Western United States." So it sort of answers the question in the title, from the Journal of Geophysical Research Atmosphere. So let me just walk us through, and then maybe we can talk a little bit about this, even though, as it turns out, you've probably only skimmed the abstract.
It's that's as far as I've got. I want to read it. I just haven't read it yet.
All right, so it's like the world's getting warmer. A warming world physically can hold more moisture. So that's sort of the context, motivation. The part of the motivation is in 2023, some of the biggest seasonal totals across the West Coast were seen. And so within that context, has anthropogenic influences influenced the climate in ways where we can detect an increase or an intensification in cool season precipitation. So with that, what's the expectation? Well, it actually turns out that there's countervailing forces, right? So on the one hand, and I sort of alluded to this, as the atmosphere warms, it can hold more moisture. And so the expectation is when it rains more, right? So one might think from that alone that a warming world will make places more wet. Well, there's other things going on too. The climate's complicated. There's also model evidence that suggests that in a warming world, that the atmospheric circulation, the movement of the atmosphere, the flow of the atmosphere will slow, and also that the thermodynamics of the atmosphere becomes more stable, so less easy for air to rise and squeeze out and rain. And so in that sense, maybe there'll be an increasing in the frequency of dry days without much rain. So there's these countervailing forces going on, and that's sort of like both model and physically based expectations. The kind of conventional thinking for the Western US is when you sort of sum all of these vectors of change, that the result would be precip would be concentrated into fewer events, and there'd be enhanced variability in precipitation totals. So that's sort of like what we may expect from theory and models. So what did they see in this paper? Like they created their own data set in order to go back to look further back in time. So that's a real value add there. So they go back to 1951. So their time span is 1951 through 2023. And again, it's the cool season, November to March period. So So in 2023, this is actually something that I didn't remember. 2000, the high seasonal totals in 2023 were driven by a combination of higher proportion of days with rain, so greater frequency. I didn't actually think that. I thought it was fewer, but also larger precipitation totals on those days. So an increase in both frequency and intensity in 2023 culminated in the record-setting rainfall in many areas. All right, so that's one thing that they saw. They also look back in time. I'm getting into the weeds here, but hopefully it's interesting. You're nodding, so you're not
I
sleeping yet.
I'm enjoying it. I don't have to read the paper now.
Yeah, that's right. Okay, so they look back in time, trend analysis at the most intense precipitation days, and they actually see no trend. In fact, the trend is either on the days when it rains, the trend is either for no statistically significant change in that intensity or a statistically significant decreasing trend. So a lack of intensification on the wettest days is basically one of the results. Again, this would be in contrast to what it is expecting, right? Like the models would project fewer but wetter rain days, wetter days getting wetter, and also that the proportion of the total rain that is coming in the season would be increasing for the wet days. So the proportion of total rain coming from really wet days would increase. I hope that makes sense.
Yeah.
All right. So there's a few contradicting things here, right? Like they're actually not seeing an intensification of the wet days, even though that would be the expectation from the models. And so they try to diagnose, well, why might we be seeing that? And again, pulling on the two main levers, the amount of moisture in the air and the flow of the atmosphere, the speed of the flow of the atmosphere. So they look at both of those. And the amount of moisture in the atmosphere is actually not changing much. So it's not that. But the speed of the movement of the atmosphere is slowed. So that is what they're attributing to these slight decreasing trends in the intensification of cool season rainfall. So any thoughts? I think that, right, the upshot there is that we're actually not, despite what we might expect, we're not yet seeing cool season rain intensifying on the days that it would rain. And that is because the flow of atmosphere is slowing.
Yeah. No, I think these studies that do this kind of like attribution, I think are really cool. And I thought just in the quick read in some of the summary points that being able to take the model projections and then think about because it's what we're talking about, and this is something we've talked about for a long time, is the challenge of seeing the signal in the noise and precipitation in the West. And I think this is especially hard in the Southwest because of our precipitation seasonality and we're an arid, semi-arid climate, right? So those precip events are very, very noisy over time. And so trying to find out when there is an attributable climate change signal in a noisy data set is really hard. So they in this papers from some of the summary elements that they presented are saying what like they expect that signal to emerge from the noise in about 2080 in that medium emission scenario for California. Is that right?
Yeah, so that's right. So they do this. They're like, well, would we expect to be able to see a detectable intensification? And they're like, no, not really. Based on realistic emission scenarios, right? Like for the Pacific Northwest, you wouldn't see a detectable signal until between 2040 and 2060. And then for the Colorado River Basin, it would actually not be in, it would not emerge until like 2090, right? So it's exactly that, highly variable. But the other thing is like you're observing a decline, a declining trend, which sort of goes against a declining trend in the wet days. So, and that is actually also contrary to what the models are saying. So you can run these climate models, you know, many times, and you can simulate historical conditions, and you can match those historical conditions to what we observe and see how well the models are actually reproducing, historical climate. And right, like the more that they align with the historical climate, the more confidence you have that the models are getting the physics for the variable that you're interested in correct,
Yeah.
right?
Yeah.
You know, and it turns out that the historical observations that some of the models do replicate it, but it's very few. That the historical observations are actually on um, they're not in the fat part of the ensemble distribution, if that makes sense. Maybe you can help
Yep.
me articulate that, right? Like there's a few of the ensemble members that are replicating it, but not many.
Yeah.
And so they actually say this in the paper that it's like, well, it calls into question how well our climate models are currently simulating Western climate variability, which is, I think, something that as a science tool, these models, that's been known quite a bit. There's a lot of things that go into trying to get the historical climate in these models correct. And for something,
Yeah.
it's not yet there. But it does add caution to the projections of precipitation.
Yeah. 100%. I mean, here in the Southwest, we know, looking at all the CMIPs over the last several generations of how difficult it is to try to tease out what we think the signal is going to be as far as precipitation changes in the winter and in the summer down here because of the uncertainty in the models. So I think that that's a real challenge. The thing that I can, again, not diving super deep into the paper yet, is understanding the real challenge of trying to measure changes in precipitation it's really hard because of our observing network, right? And so you rely on, especially if you need it for several decades, you're relying on basically daily precipitation measurements made within the legacy cooperative observer network. And we know this from a lot of other studies that have really struggled with this is that there's probably sub-daily intensity changes that we can't even like pick up on yet, right? Like, because the daily total is really only part of the story of the intensification process.
I mean, everybody that lives here in the Southwest in the monsoon
Yeah.
knows this very well. It's like
Yep.
we have daily data, but like the monsoon rain comes in 20-minute bursts or an hour,
Yeah.
you know.
Yeah. And that's, it's most likely happening during the winter season too, is that there could be real intensification occurring in how the duration of the events on the sub-daily timescale that we wouldn't be able to discern or tease out of the daily record that we have right now. But you can't get around that, right? We don't have that many places with long-term hourly data to then be able to know what's happening between the sparse network that we have in those situations. So it's a real challenge. So, but nonetheless, it's a really cool study.
Yeah. Okay, so can't really glean anything from the paper about what we expect in the next few months. But what do we expect in the next few months, Mike? What do you
This
think?
is, man, you're the master of the segue.
All right. Uh, that was a question.
Oh, that was a question? Oh, I thought it was a good segue.
That was
Yeah,
both
man, I
a,
think I
it was
think you
both a question and a segue.
it
I
was
mean,
good.
what do you think? What do we expect? What do the models say?
Yeah. Yeah, and it's what you teased us with at the beginning, and I'll hand it back to you, is the outlooks are pretty bullish on being dry, but increased probability of below average precipitation for the Southwest for the core of the winter season. And that forecast has been, or that outlook's been on the books for many months now because of the La Nina event that was forecast to show up, even as it has faltered and looks to be a very marginal event if it comes on as weak. But as you were talking about earlier, the forecast models don't seem to care and about the strength of the event at this point.
Yeah, let's get to that in a second. But you're right, because like it's been a long time where we've been talking about this emerging La Nina, and it's taken a long time to get going. And it's actually, I don't think it's crested any, it's still in neutral, by the metrics that NOAA tends to use, right? So there's at best, and I think the probabilities that it will ultimately go in the books as a La Nina is slightly greater than not.
Yeah,
But those probabilities have been declining. A lot of like, it looks like, when you take the average of the dynamical models, it's just gonna break the threshold value for becoming a weak La Nina. So it's like it's right there in the borderline neutral La Nina. And we talked about this in the past where the anomalies tend to scale with the intensity of either La Nina or El Nino, right?
yeah,
And so
yeah,
you might think then that the two things happen actually, that the confidence goes up and the magnitude scales, right?
yeah, yeah,
So in a La Nina, this is the way I think about it. It's maybe more conceptual than physical, but like La Nina's like grip on the atmosphere loosens a bit, and the and the position of the jet stream can has more latitude to move. I don't know if that's exactly physically based, but that's how I think about it. So you end up getting like the variability during neutral events to be higher than, let's say, during La Nina events.
yeah. I mean, we've even talked in the past. There's been some research that when you get weak events, that you can have sort of constructive interference with things like the Madden-Julian oscillation, and it can kind of enhance the ability for waves to come across the Pacific and even enhance atmospheric river activity, and some of that can even cross into the Southwest. So it makes the as the La Nina event gets weaker, I think it's what you said is it opens the door for more opportunity for just a couple of events. And since we're a low frequency precipitation area, just a couple of events can bring you right up to average pretty quickly.
Right. And so what is strange is that despite this weakish at most La Nina event, that the models are pretty bullish on significant dry anomalies across much of the West, with the exception of the Pacific Northwest, which has the opposite sign. And that is the classic La Nina signal, right? But again, the difference here is that the dry anomalies are real intense, real
Mhm.
strong. And so Noah's got the ENSO blog, which does a really nice job of talking about some of these issues. And they're sort of asking the question, why? Well, nobody has like a great answer, right? At the moment, like the models themselves are a little bit of black boxes. Like it takes some time to actually like tease out what's going on. One of the theories, and Mike, I don't know, maybe somebody recently published a paper on this. I'm not entirely sure, but one of the theories that was put forth in the blog is that, well, maybe it's that the traditional measures of the strength of ENSO sort of convolute a trend in warming in the sea surface temperatures. So if you subtract that trend, right, and try to actually look at the relative difference between, am I saying this right, Mike?
Yeah.
Okay. If you subtract that trend, you would get a more accurate reflection of the relative difference in the region of interest in the tropical Pacific Ocean and the surrounding ocean. So once you subtract that trend, like the values of La Nina right now actually look much more like a moderate, close
Right.
to close to the borderline moderate strong than they do borderline weak. So there might be, and so I think the paper that was published, correct me if I'm wrong, the paper that was published was talking about this new relative insometric.
Yeah, that's some of our friends and colleagues at the NOAA Climate Prediction Center have that relative oceanic Niño index that they've been working on.
We should post that too in
Yeah,
in
it's in the latest ENSO blog that you mentioned earlier. They talk about it in there.
yeah. So that's the deal. I mean, maybe I mean, again, we should always mention that this is no guarantee. These are not deterministic forecasts, right? There is a range of possible outcomes, but when you take the mean of them, it's suggesting a dry winter for us in the Southwest and a wetter winter in the Pacific Northwest. So that's what we
I
might expect.
Right. I was reading one of the NOAA blogs, or actually one of the forecast discussions this morning, and it was diving a little bit deeper into the so we in these situations, especially to the winter season, northern hemisphere winter season, and especially when we're kind of transition, we're going to look at the Madden-Julian oscillation activity, and it's actually the Madden-Julian oscillation I think has been the probably the biggest determinant of some of the recent weather patterns in the probably the last 30 days or so, because it actually made a full pass around the planet and was probably part of our kind of earlier rain event and then some of the ridging we've had in the past. And so they were talking about in this discussion that sometimes that oscillation will constructively interfere with the La Nina base state. So the La Nina is trying to get going. And so you've got this other oscillation in the atmosphere that kind of rides over top of it and they start to work together. And apparently it has created a westerly wind burst and enhanced the trade winds along the equator. So what that could suggest is that it's the sub-seasonal variability. It's so hard for the models to pick up on, might actually strengthen the La Nina event over the last. So they might get the right answer, might get the right outcome without knowing that this was
Right.
going
Well,
to happen.
these models aren't seeing that
No,
yet.
they're not seeing that, but they see right. And that's what's interesting is the NMME, National Multi-Model Ensemble with all that, I think it's hard for me to get my head around too, because the teleconnection pattern is a teleconnection pattern. So it's picking up on a La Nina like state, even if the sea surface temperature forcing isn't as strong. And so that's where I still don't get. I think as everything warms up, the pressure gradients and the sea surface temperature gradients change, and so I would expect the teleconnection to change as well, either weaken or strengthen. And so that's what I find is interesting is that the models are still really picking up, even if it's a weak La Nina event, still saying, you know what, it's going to have a strong La Nina like atmospheric response. So I mean, yeah, in these situations, anytime we tilt La Nina, I start to it's such a it's such an easy it's so easy for the Southwest to go dry during the winter because we don't have a lot of events anyways. You lose a couple, you're already behind, and then the season's over. So like a dry forecast in the Southwest is an easier forecast to make. I mean, it'd be great if this we broke out of it, but I'm leaning dry now too.
So what you just said reminds me, or makes me want to sort of do a deeper dive, maybe next episode, Mike, into the Madden-Julian oscillation. Because I mean,
Yeah, yeah.
there's more to this. I mean, again, these models, like the patterns that they show, like just suggest it's like ENSO driven, but there's more going on and there's more constructive and destructive elements of like the Madden-Julian oscillation and others. And we should maybe
Yeah.
try to unpack that. And then there's been a lot of activity on subseasonal forecasting and even weather forecasting, like artificial intelligence,
Yep.
like
Yep.
Google DeepMind,
Mhm.
NVIDIA, Microsoft, Huawei. They're all getting into the game with these artificial
Right.
intelligence that is actually they're not physically based, right? Like they're
No, no.
but like a new paper was just published, and maybe we can deconstruct this. They're now performing better than the best physically based um, atmospheric weather models from the European models. The European models are the best, and they're actually outperforming them in like 90% of the metrics, or maybe even more than that. I've got it right here.
So wild because the the inherent part.
97% of the 1,322 targets, these new AI models are outperforming the best physically based numerical weather prediction models.
So wild. It is so wild. And the thing is you couldn't explain why. That's the wild thing about these AI models. The attribution is like, I don't know.
The attribution is, well, they're smarter than us.
That's it. Right. Exactly.
All right. Well, yeah, let's think about that for the next episode and leave that for the listeners to come back for.
That sounds great, man. That sounds great.
All right. Well, Mike, as always, thanks a bunch. And if I don't see you, happy holidays.
Yeah, have a great holiday and maybe we'll see a rain event. Wouldn't that be nice? Maybe it'll be a Christmas Eve rain event. We won't probably get snow, so we can't really count on that. But yeah, we'll come back in the new year and try to see what we're looking at.
All right. And thanks to Stacy Reese for producing this and to all of you for sticking with us this long. Take care.
Thanks, everybody.